There it is. I'll wait a minute or so to see if they do the attendance. Not the attendance. I'm sorry, the pledge. And a lot of people are coming in the room right now, so let me participant by Lynn. Madiska. Who's that? That's Rebecca. Miss Ocampo. And Milani. Costa. Anybody else? Okay. Let me admit all of them. One, two, three, four people. I'm still missing. Up there's. What's wrong with Aaron? Why is he having trouble getting? Oh, okay, Aaron is now in. All right, guys, make sure you put yourself in attendance because I'm not going to even open up Infinite Campus right now because I want to use as much time as possible to wrap up what's important about partial fractions and make sure I do it right by checking for. Uh, oops, sorry, I didn't mean to turn you upside down. Sydney's here. Allison is here. Sydney, you came in, right? Did I see Sydney come in? Yeah, Sydney came in. All right. Uh, let's continue. Now they're going to do the pledge. All right.
Good morning, my high. Please stand for your pledges. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Now you take this pledge. Honor the Texas flag. I pledge allegiance to the Texas, one state under God, Make sure that you stay 6 feet away from each other. Thank you so much. Have a great Friday.
All right, guys. Number one, if you recall, I did not take into account that it was an improper fraction. So what I ended up getting was only part of the answer. And remember where the 2x came from. The 2x came from the long division, which was, as I think it was Elena who said, remember the first step was do the long division if it's improper. And I dropped that ball because I never really do partial fractions with improper. But I learned something. So now I'm gonna erase to get my room here. I just need, oh, that's not erasing. That's erasing. Okay. I'm going to copy this number 2 problem on a separate page because I wrote all over this. So I'll just, I think I can do a, let's see, how can I do it? I got to make a edit. I think I got to make a copy of, oh, and I got to do this. That's what I got to do, this. I'm going to do this problem right here, that problem there. And I will copy that piece and put it on its own page. So that way I'll have more room. There, okay. So we're going to find this one here. Now, it's definitely proper, okay? So I won't be making a stupid mistake. Well, I might still make a stupid mistake, but it's proper. The thing I noticed, though, you see this linear term, the x minus 1? It's actually repeated. How many are there? There's 3 of them. Which means, if you remember when we were doing the directions, what I have to do is I have to factor that bottom. So it becomes 2x over x minus 1 times x minus 1 times x minus 1. And when it's a repeated linear term, you're still going to have a constant on top over the x minus 1. But because this is the second of them, I have another constant on top, but I do an x minus 1 and I square it. And because there's 3 of them, and it's still linear, I do a plus c over the x minus 1 cubed. Okay? So that's what we have as my 3 fractions. I just got to find a, b, and c. Now remember what I did the other day. If I want to get rid of the denominator, I multiply by this side the denominator, all 3 of these, and it turns out to be 2x. If I multiply all 3 of these on the right side, then the x minus 1 cancels 1 time. So the a is left with the other x minus 1 squared, and it's left with the x minus 1 cubed. Plus b, the x minus 1 squared will cancel out, leaving the x minus 1 and the x minus 1 cubed. And the c will be multiplied by an x minus 1, one of them, and the x minus 1, the second of them. So the secret is this, guys. The secret is when you want to create your important line, whatever denominator is not here, this a has to be multiplied by the other 2 denominators. So this b has to be multiplied by this denominator and this denominator. This c has to be multiplied by this denominator and this denominator. This is your important, your very important equation, okay? Don't lose it. This is what we're going to use to find out what a, b, and c are. Now, here's the problem. Let's see. If I let x equals to a 1, that would be bad news. X equals to 1 does not work because 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. So then I end up getting 2x equals to, I get 0 equals to 0 because 2 times 0 is also 0. So I can't use x equals to 1 like I did in the other problem, but I can use any x that I want. You don't have to use those secret x's, you know, you can, let me see if I wrote my problem right here. X minus 1 squared, x minus 1 cubed, 2x, okay, that makes sense. I'm trying to see what the, in the notes, he's saying I have an a times, trying to figure out why. Oh, I know why. I know why. Let me back up my important equation that is. It would work, but it's going to give you a lot more work. It's going to be more steps. I don't need to multiply both sides. Don't copy this down. I'm going to show you. I don't need to copy by all three. If I just multiply by the x minus 1 to the third power, that cancels all three of those out. So if I multiply all of this by just the x minus 1 cubed, I don't need to have all of them, because this x minus 1 will cancel. That will leave me an a just times an x minus 1 squared, because this is an x minus 1, x minus 1, x minus 1. So one of the x minus 1s will cancel. The b, since I'm canceling out 2 out of 3, I'm left with an x minus 1. I only have one of them left. The c is over the x minus 1 cubed, so if I multiply by, who's that? That's okay. If I multiply by this fraction by the x minus 1 cubed, it cancels the whole thing, so it just leaves the c. That'll be easier than what I had. So there your 2x. Same thing, still 2x. Now I can let x equals to 1, because x equals to 1 will force this to be a 0, this to be a 0. What that leaves me, I think, is a 2 times 1, which is 2. That's a 2 times 1, equals to a 0 plus c. So c is 2. So I already have one of the answers. Okay. Now the question is, how am I going to get a and b? Okay, that's going to be a little harder, because the only one I was able to get was when, so I can use any x I want. Let me use, let x equal to a negative 1 and see what happens. So if x is a negative 1, that gives me 2 times a negative 1 equals to an a, and I always try to use easy numbers. A times, what's a negative 1 minus 1?
0.
I said a negative 1 minus 1.
-2.
Yeah, I tricked you. It does sound like 0. 1 minus 1 is 0, and I already used the x as 1. So now I'm using a negative 1. So it's a negative 1 minus 1. That's really a negative 2, as I heard Sondo say. And that negative 2 is being squared. So I'm going to put that there. Plus my b times a negative 1 minus 1 to the first power. That's just going to be a negative 2 again. And then I have a c that has no x's, so I'm going to put a c. But I already know what c is. C is a 2. So let me clean this up. And please stop me when I do something dumb. 2 times the negative 1 is a negative 2. Negative 2 squared is a 4, so that gives me a 4a. Negative 2 times b will give me a negative 2b. Then I have my plus 2. So you might not realize this, but if I subtract 2 from both sides, it turns into a negative 4 equals to 4a minus 2b. And I know what you're thinking. Ha ha, nothing canceled. I still don't know a and b. You're right. But what I'm going to do is I'm going to use another x. Any x I want to use. It doesn't really matter. You can use x to be, see, now I did a 1, I did a negative 1. What if I make x equals to 0? or x equals to 2. It doesn't really matter. Pick any x you want. I'm going to let x equals to 0 because it's really simple. Look what's going to happen. I'm going to plug it in again to that big, long equation. 2 times 0 will equal to a times, what is 0 minus 1? Somebody?
Negative.
That'll be a negative 1, and I have it squared. Plus the b times 0 minus 1, again is a negative 1, and it's to the first power. And I still have plus c, but I already know what c is. So I'm going to simplify this. 0 equals to a negative 1 squared is 1. That leaves me a. And a b times a negative 1 is a minus b. And then I have my plus 2. Move that plus 2 over. Negative 2 equals a minus b. And again, it didn't help me find a or b, did it? But look at, I now have two equations with a and b in it. What do we call this in Algebra 1? Anybody? What am I looking
System.
at? A system, yeah. I can use any x's I want and create two equations. Since I already knew what c was, I will always have an a and a b, no matter which x's I choose. So now I just solved this system. Let me ask you a question. Do you want to solve it with substitution, elimination, or do you want to use Gauss-Jordan method with matrices?
Elimination.
Yeah, you're very smart. You're very smart. So if I multiply the bottom by a negative 4, that gives me a negative 4 equals to 4a minus 2b. The bottom becomes an 8 equals to a negative 4a plus 4b, assuming I don't do anything stupid. And I don't hear Sondos yelling at me. Please yell at me, Sondos, when I add straight down. This gives me a 4. I add straight down, that cancels. I add straight down, this gives me a 2b. So b must be a 2. Yay! So if b is a 2, then take any equation. I'll take the negative 4 equals 4a minus 2b. I'm going to plug in my b equals to a 2. Negative 4 equals to 4a minus 2 times 2. That gives me a negative 4 equals to 4a minus 4. Does that give me a as 0? Did I do anything wrong? Could a be 0? I don't know if I wanted 0 there, but so I'm asking you. Anybody? Bail me out. Nobody's going to talk to me?
Yeah, it's 0.
Okay. I said I didn't think it was, because why would it go away? So go back up to my problem, and I'm going to write this again. I'm going to write the same problem again. Write 2x over, technically it was x minus 1 cubed, is really equal to, a was, what did we say a was? A is a 0. So I don't have, I could put it 0 over the x minus 1 to the first power, plus my b was, what was b? B was a 2. So it's plus a 2 over the x minus 1 squared. And then my c was also a 2. So it's plus 2 over the x minus 1 cubed. This goes away. So my final answer is, that whole problem was 2x over x minus 1 cubed is broken down into two parts, two fractions. 2 over x minus 1 squared plus 2 over x minus 1, that was a cubed. So that's my story, and I'm sticking to it. Why is it called partial fractions? Because you took this thing and you broke it up into two parts that are they're identical to this original problem. That's supposed to be a 3. All right, moving on. number 3. Let me, I don't know why, I think I wrote on it because let me copy this problem. Wait, do I have another problem down here? Maybe it's by itself and I don't have to copy it. No, I need more room. So let me copy this. Copy that. Copy it. A new page. Paste it. All right. So there it is. So I want to turn this into partial fractions. He's already got it factored. Oh, was it really? It's already factored. But look at, this is linear. This bottom piece is linear. This bottom piece is quadratic. But they're not repeated. There's only one of those linear terms. There's only one of those quadratic. So what do I do with a linear term? I put it an a on top because it's just a constant term over the x plus 1 plus over the x squared plus 2. I have to put a linear term on top because that's quadratic. So I'm going to put a bx plus c because that's mx plus b. There's my linear term. Okay, take a deep breath. Do you see what I did? So now I know that if I multiply both sides by the denominator, I'm going to have, here's my important equation. X squared plus 3x minus 1 is equal to, the a gets multiplied by the x squared plus 2, and bx plus c gets multiplied by the x plus 1. So I'm not really going to do all that extra work. I'm just going to say a needs this denominator, this numerator needs this denominator. So I'm looking at this problem. Is there any easy x's that I can cancel out? What if I say let x, I'm going to put my line here. What if I let x equal to the negative 1? Won't this go to 0? And wouldn't 0 times this also go to 0? Hello?
Yes, sir. Yes.
Okay, so I'm going to plug in the negative 1 in every x. Negative 1 squared plus 3 times negative 1 minus 1 is equal to the a times the negative 1, don't forget it's squared, plus 2. And I don't have to plug it into this because you already told me this goes to 0, right? So let's clean this up. Negative 1 squared is 1. 3 times negative 1 is minus 3. Bring down the minus 1. Equals to an a. Negative 1 squared is a 1 plus 2. That turns into 1 minus 3 is a negative 2. Negative 2 minus 1 is a negative 3. Equals to distribute. Well, I don't have to distribute. It's 3a. I have a. What's a?
Negative 1.
Negative 1. So now, unfortunately, I can't get rid of this because nothing squared plus 2 is ever equal to 0. Because this would have to be a negative 2, and if you square it, you'll never get a negative 2. So I'm stuck. What am I stuck with? I can't make the a go away. So I have to use any x that I want to use. Give me, I already used negative 1. Give me another number that's as easy as a negative 1.
0.
0's great. 0's great. And I heard somebody say a 1. That's also great. I'm going to use a 0 though, because let x equals to 0, because that'll plug in very easily. Now look what we get. I'm going to get a 0 squared plus 3 times 0 minus 1 equals to 0 squared is 0. 0 plus 2 is 2. That gives me 2a. Next piece. Plus b times 0 goes away, leaving a c. 0 plus 1 is still 1, so it's a c. This turns into 0 plus 0 minus negative 1 equals to 2a plus c. Oh, no, I got two unknowns again, don't I, or no? I already know what A is. A is already a negative 1. Ta-da! Negative 1 equals 2 times negative 1 plus C. Negative 1 equals negative 2 plus C. Add 2 to both sides. C must be equal to 1. Yay! I got A and I got C. All right, I don't know who was in the background a minute ago who told me use let x equals to 1. Since I need another one, I will let x equal to 1. Okay, I could have done that before, but I'm going to do it now. All right, so I need, I can't zoom in enough to write because I can't see the red there. I have to make it small to get down there. Could somebody do me a favor? Plug in a 1 everywhere and you tell me what to write down. Okay, tell me what to write down because I can't see it.
It's 1 squared
Okay,
plus 3 times 1
okay,
minus 1
okay,
equals to the, a times 1 squared plus 2
okay.
plus b 1
B times
plus
1,
c.
which is B, right?
I mean, yeah, plus
Plus,
c,
plus a
and
C. What'd you say?
it's b times 1 plus c, which is b plus c,
Plus C, okay, times.
and then x. Oh, I mean times 1 plus 1, which is 2.
Oh, okay, it turns into 2. Thank you. Anybody disagree with her? Was that Elena?
Yes, sir.
Elena, I am just so impressed lately. You've just been on fire. Thank you very much because Santos needed a break. 1 minus, no, plus 3 minus 1, it has to be equal to a 3a plus 2b plus 2c. But I already know that a was a negative 1. So a is a negative 1 goes here. And I already know c was a 1 goes here. So let's see what I got. 1 plus 3 is 4. 4 minus 1 is 3. 2 times a, which was a negative 1. I'm sorry, 3 times a negative 1 plus 2 times, I don't know b, so 2b plus 2 times a 1 leaves just a b. So 3 equals negative 3 plus 2b plus 2. That's 3 equals to a negative 1
Sir,
plus, yeah.
where'd you get that 2B from?
I distributed this 2 right here.
Okay.
Okay, am I okay? All right. So 3 equals to a negative 1 plus 2b. 4 equals to 2b. If I'm right, and I'm going to say if Elena and I are right, then b is equal to 2.
Yeah.
So that would give me, let me write that, let me write it up in there. A was a negative 1 somewhere. A was a negative 1 and b is a 2. So that gives me A is a negative 1, B is a 2, and C was a 1. So let's finish putting the problem. The original problem was, I'll just do this. I'll cheat. I'll just go paste again. Paste. It's still there. Yay. That was the smartest thing I've ever done. Equals to, it was an A, which is a 1, over the x plus 1, plus the b was, what was b? I can't even see my writing. B was 2. I don't know what happened here. We didn't write. B is a 2. So that's plus 2x plus a c, and c was a 1, all over x squared plus the 2. There it is. There is the original ugly, ugly
Sir,
rational. Yes.
the one on the first fraction?
Yeah, it was a negative, right? Was it negative?
Yeah.
Yes.
Oh, okay. Yeah, I remember that. I don't know why I didn't write it. So, and I even wrote it right here. I don't know. I'm brain damaged. Uh, this ugly thing, I broke it into two partial fractions, two different parts. Was it easy? No. It was hard. It was a lot of work. But I think those three problems, guys, if you can redo those three problems on your own, then you know everything you need to know for partial fractions. Is there more work in here? Yeah, but I don't really care about all of it. I'm actually, let's see, what are they doing here? Uh, this is a repeat of what we already were doing. I'm not sure why he has another chart asking me for more steps.
So I don't know if you know, but you skipped one.
Oh, is that the problem? Oh, on the other page?
Yeah.
Over here? On this page? Oh, okay, let's do it. Okay, it's a repeated
Wait,
quadratic. It's a repeated
are we
quadratic.
gonna have enough
Pardon me?
quiz?
Yeah, you're gonna have
Are
it.
we gonna have enough time?
Yeah, because she stopped me at 10:10. I'm gonna set this up
Okay.
as much as possible. 2x over the x squared plus 1 squared and the x minus 1 there will turn into, I'm just going to set it up for you because I already gave you all the secrets. A, that's a quadratic. So it has to be ax plus a b. It has to be a linear term. And it has to be over x squared plus 1. But because it's repeated, too bad, so sad, cx plus d now is over x squared plus 1 squared. Plus, now I have a linear term right here. So it's going to just be an e, linear, a constant, over the x minus 1. So what's going to happen? If I actually have two of these terms, so my least common denominator actually is an x squared plus 1 squared and an x minus 1. So if I multiply this by this component, the x squared plus 1 goes away, but I'm still left with 1. So it's going to be ax plus b still times 1 of the x squared plus 1s and times the linear x minus 1. It's ugly. This is going to be so hard to do. I'm not going to have time to finish it. Plus, if I multiply this by this common denominator, this thing goes away, just leaving an x minus 1. So this one's not so bad. This is going to be cx plus d just times the x minus 1. This one is going to be left with the x squared plus 1 squared. So plus e times the x squared plus 1 squared. Yeah. So that's what is equal to 2x. That is just a 2x. There's your important equation. My x's that I would try to use first, I would use x, let x equals to 1 first. Because that cancels all of this one. It cancels this one, and it'll cancel this one. That'll only leave you with this term here. So 2 times 1 is 2 equals to, this goes to 0, this goes to 0. So I'm left with an e times a 1 squared plus 1 squared. 2 equals to e times 2 squared. 2 equals to 4e. E is a half. Bad news is, I still have to find A, B, C, and D. So you're going to have to create more equations. But I'm not going to have time to do it. And I'm just going to say to you, if you want me to finish it, I can post it in a video. I have the first video for the first half, the problem number 1. I have that in a video already. I can post that, and I can finish this as in problem number 2. Is that what you would rather I do? I'm gonna be honest with you. I would
Yes.
never give you one like this for homework. I mean, I might give you one for homework to try it, but I would never make you do this on a quiz or a test. Because it would take you a half hour to finish the problem. So I would not do that to you. But I will finish it and post it this weekend. I'll post both videos for you. Your quiz today does not have partial fractions. Okay? I will close my mouth and you go ahead and you can stay in Zoom and do your quiz, or you can log off and go to your My Math Lab and do the quiz.
Sir, if on the quiz they ask us for like to use like elimination or something, do we have to use that method in our
Yes.
work, or can we use
Yes.
it?
That's why I said you have to submit a picture of your work and its learning. I want to see that you did use elimination. I want to see that you did use substitution when it asks you. Okay?
Oh, okay.
I think I only gave you 5 problems. 4 or 5, I don't remember.
Bye, sir.
Bye. Have a great
Bye,
weekend.
sir.
Bye. Thank you, Elena.
Bye.
Bye-bye.